Hello scientific people. So today I'm going to discuss problem number 9.24 grade 12 physics ray optics NCERT textbook. So here is the question that you are able to see on the screen, and I have specially highlighted a word that is least converging over here. So I will explain you the meaning of this question. In these two cases, the human eye, a normal human eye, is witnessing two different objects kept at infinity, kept at the near point. So here the object is at infinity and the rays are parallel falling on the eye lens, and finally the image is obtained on the retina. This is retina. Here the object is at a distance of 25 centimeters away from the lens, and finally again the image is formed on the retina. So whether this is the case or that is the case, the final image is formed over here on the retina, final image is formed over here. So I can say that in these two cases there is one similarity, that is image distance is same over here and here. Here object distance is infinity, here object distance is minus 25, but here the image distance would be something, this distance, here the same image distance would be there, right? But apart from that, here the cornea is also behaving as a convex lens, because they have given that the power of cornea is 40 diopters. That means it is behaving like a convex lens. So first thing, that the rays are going to fall on the cornea, it is going to do slight conversion, then the another conversion would be done by the lens, eye lens, and finally the image would be formed on the retina. So basically I can say that for the combination of lenses, so this problem can't be solved without considering the concept that these two lenses are combined. So this is a combination of lenses, and for the combination the object distance is given and image distance we would be finding out. And why this is the least convergent case, let us discuss that. So this is the case where the converging is being least, and the power of lens in this case is 20 diopters. So that means I'm going to use this formula, power equivalent is equal to power of the lens plus power of the cornea. If we are given two lenses, then equivalent power is equal to the sum of their powers. Now since both of these are convex lenses given, so the equivalent power is going to be 60 diopters, and if I find the equivalent focal length, that is 1 upon power, that is 1 upon 60 diopter, and I know 1 upon diopter is meter. So F equivalent, that is equal to 100 centimeter upon 60, which is 5 by 3 centimeters. 1 upon diopter is meter and 1 meter is 100 centimeter. Now in this case the equivalent focal length is 5 by 3 centimeters. Now let us understand why this case is referred as the least converging case. Here I have a thick lens, here I have a thin lens. When parallel rays coming from infinity fall, the thick lens bends the light more. So if the light bends the more, the light falls very near to the optical center, and that point becomes the focus. So if the bending of the light is more, like this, then the focal length becomes less and more powerful is the lens. Thicker lens, more powerful lens, they bend the light more, focal length is less. Thin lens, they bend the light less, so the light falls very far away from the optical center, focal length is large. Less powerful lens. Less powerful lens bends the less the light bends over here, over there, focal length is large and the power is less. So this case and this case are same, because when we see very far away objects, the eye lens becomes thin, so conversion is least. Whereas when you see the nearby objects, the eye lens becomes thick, the conversion becomes very large, like this one. So these two are same and these two are same. So that's why this is the case in which the least conversion takes place, because the lenses are thin, the focal length is very large of this one. Beautiful thing is that in these two same, the cornea remains intact, no role of cornea as such, its focal length and power does not change. But most important thing, here the focal length of the eye lens would be less, here the focal length of the eye lens would be more. So if you might be wondering what is the difference between these two, is this distance, because here you are looking at faraway objects, eye lens becomes thin, That is called the accommodation, and here the eye lens becomes thick. So now let's apply that concept over here. Since I am being given the power of lens and the power of cornea, and this is given for least converging case, so please don't use this in this case, otherwise your answer would be wrong, because I have explained you why to use this in this condition. Now 1 upon f equivalent is equal to 1 upon v minus 1 upon u. I am supposed to know the focal length, equivalent focal length of these two, which is calculated over here. The 1 upon 5 by 3 centimeter is 1 upon v minus 1 upon infinity. So the equivalent, the final image distance is plus 5 by 3 centimeter, which I receive it from here, and I know now that this image is formed on the retina, so I know this distance, and this distance is going to remain same over here, so this value can be used over here also. Now 1 upon f equivalent, that is equal to 1 upon v minus 1 upon u. So 1 upon f equivalent, that is 1 upon image is formed again at this distance. This is plus 5 by 3 centimeters. Image is formed again over here only. So plus 5 by 3 centimeter and minus 1 upon minus 25 centimeter. Why is that? Because the image is formed behind the lens, so positive. Object is in front of the lens, opposite to the incident ray, negative. Please don't make any error in the unit, it is going to be a bit confusing. I am multiplying up and down by 5, so 15 by 25 centimeter plus 1 upon 25 centimeter. So my answer 1 upon f equivalent is 16 by 25 centimeter. You see that 20 centimeter is written down, correct? So 1 upon f equivalent is power equivalent. That is equal to 16 by 25 centimeter. That is 16 upon 25 by 100 meters. I am converting this into meters. So this is 1 ja 4 ja. So this 4 goes up. So power equivalent is equal to 60. Have I done it correctly? Yes, 64 diopters. Yes, no error over here. Now I know this is the equivalent power. In this equivalent power, power of the lens and power of cornea are combined together. And the power of the cornea, we already know that it is 40 diopters. It is not going to change. So the power of the lens plus 40 diopter is 64 diopters. So therefore power of lens is equal to 24 diopters. So this is what we were supposed to know. This is the accommodation. Accommodation means we require the focal length ranges. If we convert these two, we would get the focal length ranges for these two cases, and that is what is accommodation. Hopefully guys, you have understood this problem well. Please comment if you have any doubts related to this problem. Thank you.